If you fire a neutron at uranium-235, it will fission. Uranium-235 is fissile, we say. It's capable of undergoing fission. And look, it's a radioactive decay kind of process. It's probabilistic. It doesn't decay immediately. There's some probability that it decays in the first second, and in the second second, and so forth. Now, let's do that again, but with a bunch of uranium-235 nuclei. I'm going to fire one neutron, and look at what happens. Wow, it's like a domino effect. How is this one still around? Oh, there it goes. That's pretty cool. Oh, one little guy didn't get hit. So why is this happening? Well, let's watch a single nucleus again and count. We fire in one neutron. How many free neutrons are released? Look, there they are, 3. So when you have the chain reaction, you fire one neutron at this guy, and 3 more pop out. So for this one fission, 3 more fissions occur. And then for this guy, 3 more occur off there, and so forth for each of the nuclei that we hit. And that's what causes the domino effect. That's what happens in a nuclear reactor, in a nuclear power plant. We have fission. Whoops, let's try again. Okay, and the chain reaction occurs just like we saw before. But as this chain reaction is happening, let me put the control rods back in and look at how quickly the reaction stops. That's because the neutrons get absorbed by the control rods, so they can't continue the fission process. So if you want to control that reaction and make it happen at a slower rate, you just raise and lower these control rods. That's what nuclear power plants do. There's one last concept for us. Let me try this again with uranium-238. What just happened? Uranium-238 does not fission. It is not fissile. So if you fire something at uranium-238, fire a neutron, the neutron just gets absorbed. So there is some critical mass, we say. If you have this many uranium-235s and this many 238s, well, that's not enough to start a chain reaction. To get a chain reaction going, you need some critical mass, because watch what happens. See, so it's not really a chain, there's too much 238. To start a chain reaction, you need some critical mass of the fissile uranium. And now, even though there are these 239, 238s in there, we still have enough uranium-235 to keep the chain reaction going. That uranium-238 is a lot like the control rods. So when we raise those control rods and put them inside put them alongside the fuel rods, the uranium, it kind of acts like these inert, non-reactive 239 nuclei. Those control rods absorb neutrons, and they reduce, they kind of take us outside of the critical mass.